Good afternoon, everybody, and I just want to thank the organisers for this opportunity to speak today. I'm sure most of you have already gathered quite a lot of learning from this event. In particular, it's very, very difficult to eat rocket with one hand and have a polite conversation at the same time. So I broke my golden rule of never actually having salad at one of these events because you always look clumsy. What I'd like to talk to you about this afternoon is just really some of the journey that we've been on Western Power, in particular regarding substation monitoring, its importance, its background, but also some practical hands-on experience. I am in the very fortunate position of being able to spend my days rolling around on substation floors fitting CTs, but then also getting dressed up and coming down to Westminster, so it's quite an exciting role to have. So the agenda that I'm going to be going through is just the obligatory introduction to Western Power, talk a little bit about some of the challenges that we're facing as a distribution network operator. Many of those we've probably actually covered already this morning, and then just look at some case studies from some of our low carbon network fund projects. So Western Power Distribution, we are the network operator with 4 of the old DNO licence areas, so DNO distribution network operator. So East Midlands, the Midlands, South Wales and the South West. Effectively, we stretch from the Lincolnshire coast up in Skegness down to the Isles of Scilly, and we've managed to brilliantly put research and development projects on the Isles of Scilly and in Skegness as well. So it means plenty of travelling for my team and for my colleagues in my team. In terms of network, we supply 7.7 million customers, which we could come into an argument here with UK Power Networks as to who is actually the biggest DNO in the country, but we've got more network than they have, so I think we win. Just in terms of looking at the whole electricity distribution chain, or electricity network chain, we've already touched on how this is very much the traditional view at the moment of large centralised generation into the national grid, a transmission network, and then Western Power fill this role in the middle of actually distributing the electricity from the national grid to homes and businesses. Now that's very much the traditional view of electricity flowing one way through the network. But what we're seeing over the last few years is the emergence of low carbon generation coming in at all voltage points on our network. In particular, we're seeing solar panels coming on at the low voltage at the customer end of the network. And interesting enough, I had a conversation with, that was mentioned earlier on today about the feed-in tariff. I had a conversation with one of the guys from DEC that works in the feed-in tariff team, and they said the primary reason for doing that work, for doing the feed-in tariffs, isn't to actually encourage low carbon generation. It's actually to encourage customers to engage with their energy. And so what we'll see in terms, I think, overall of what we see coming from solar panels will be a very, very small proportion of the UK energy generation in the long run. So it's just a passing comment. So those are challenges that we're seeing today already coming onto our network, and we're beginning to see constraints at all voltage levels. We're also seeing a number of low carbon technologies coming onto the network and particularly being forecast on there. And again, there's been mention this morning of electric vehicles and heat pumps. So what does that do to our network? And I'm afraid I'm going to get slightly techie here. But we end up with a number of issues that we've not really had to face on a wide scale level across our network before. The voltage rising or dropping on the network based on these additional loads and generation. Issues potentially with voltage stability and harmonics, so things to do with the power quality as it comes through. One of the big challenges, though, for us is the electricity flowing the opposite way through the network to which it was originally designed. So Skegness, for an example, is now a net exporter of electricity due to some large offshore wind farms and some other wind farms embedded in our network at 33,000 volts. So some particularly significant challenges. Now, this is, I won't say it's one of the doomsday slides, but it's one that shows a potential scenario for how electricity could become more important as a vector in terms of energy usage. So this is looking from the 1970s through to a forecast in 2050. And this particular forecast that showed from around about 2020, we would see a large uptake of electricity as part of the UK energy mix. Now this has significant implications on us as a distribution network operator, having to try and accommodate this extra amount of load on our network. Now, interesting enough, I suppose we've all been aware of the financial crisis and the way that these predictions may have actually been scaled back since then. And we expect to see there will be some level of uptake on this, but as to what that level looks like, there is still quite a great level of uncertainty at the moment. So in terms of our program, what are we doing in terms of research and development to look at some of these areas? So our Future Networks program is very much designed looking at 3 different aspects. One is, how do we run our network better? How do we run it more efficiently? How do we use this new technology to help us in running the network? Secondly, how do we help the customer? How do we help them in terms of their own low carbon agenda? How do we help facilitate them, whether it being a domestic customer all the way up to a large scale generator or a large industrial user of energy? And then thirdly, how does that then affect our overall performance as a company? How does that then impact on our efficiency and on our overall performance? So I won't go into detail on all these, but this is just a smattering of some of the projects that we're doing through the Low Carbon Network Fund. And at the end of my presentation, there's actually a website address which can give you further information on these projects. One up in the top right corner that I'll just mention in passing is we've been doing a project with National Grid to look at how we can actually create a link between our own control system at Western Power and the National Grid control system, and actually pass information between the 2 organisations in terms of generation information. So that's one that we're kind of actively looking at the moment, and I expect a report to be produced on that to be published within the next few days. So looking back at our network, let's start getting into the nuts and bolts of it now. With all these new challenges coming on, one of the issues that we've got is to do with visibility. And has already been hinted at and Roger covered this morning, we have quite a lot of visibility at the high level of our network. The large substations, 132,000 volts, which is very much akin to the kind of telemetry that's available with National Grid. But as we go down through the network, 33,000 volts, we've got, again, fairly good visibility. You then get to the substation where the power comes in at 33,000 volts and leaves at 11. We've got visibility at that point, and from that point on, it really diminishes in terms of how much we know. And particularly when we get down to the customer end, we've got no visibility at all. Now, smart metering will look to fill quite a large chunk of this gap. It will really help us understand what's happening, particularly in terms of voltage and in terms of aggregated data. When we start to aggregate the data together from different smart meters, that should help us get a real feel of what's actually happening at this end of the low voltage end of the network. But substation monitoring will play a part in this. It will not be a solution that we look to put in everywhere, but it will be something that we're going to put in on our network. And I just want to cover through some of the things that we're doing. So, what does a substation look like? Let's start at the basics. So this is one of our ground-mounted distribution substations. On the left-hand side there, you've got a cabinet with power which will be flowing out through a number of different cables at 230 volts. It flows in originally through a switch on the right-hand side there at 11,000 volts, and at the back of the unit, which you can't see there, there'll be a distribution transformer that will change the voltage. The photo on the right is just showing the cabinet as it's opened up. Now, within Western Power, we've got approximately 60,000 of these ground-mounted sites, so it's a fair number of sites to be looking at. Some of which will be housed internally in brick buildings, some within glass-reinforced plastic houses, or some that are just out in the elements. You may also be familiar with pole-mounted transformers, of which we've got about 126,000 of them. So again, we're talking fairly large numbers here of sites that we're trying to manage. Again, we've got the power flowing in at 11,000 volts through the overhead line at the top, and then flowing through the transformer and then out at 230 volts off to customers. So the challenge is, with installations like that, how do we actually look to monitor them? How do we look to get information back from them? I suppose the first question, though, is what actually is a substation monitor? What does it need to do? So this is on the left-hand side there, that's meant to represent one of our cables coming out of our substation to the fuses. And the first thing that we would need is some form of sensor. We will need power, actually, because I've did my slide build the other way around. So we need something to actually power the substation monitor. Now, there's a range of different practical ways that we can get power at the substation. There may already be plug sockets we can use, but there are some real challenges for us, and how do we actually look to power these devices? Secondly, we will need some form of sensor, something that will actually measure the power flow. And one of the most successful things we found is some form of sort of donut type arrangement, some kind of current transformer, which fits around the cable. And what that does is it picks up the current as the cable actually flows through the unit. There'll need to be some form of interface then, so some way of actually wiring the device in, some way of it actually processing the information, and then a processor that actually gathers the information and gets it ready to be sent back. And then finally, some kind of communications module. Now, at the simplest level of this, we have already some form of current transformers, some kind of sensors that are already embedded within our substations. And these will actually feed to a dial at the top there that shows what the maximum demand has actually been at that substation over any one period since it was last read. From a communications perspective, how we get the data back is a man in a van who goes out to actually read that maybe once or twice a year. And so therefore the power source for that would actually be bacon sandwiches. So in terms of just to actually think about where we've actually been on a journey through the Low Carbon Network Fund projects. Originally we started with a project in South Wales called the LV Network Templates. And the plan with this one was to actually look to monitor a large number of substations across the South Wales area. What we recognised is that the existing CTs, the existing current transformers in the back of the low voltage pillar, so behind those white fuse carrier handles on the photograph, were insufficient for the work that we needed to do. They weren't accurate enough. So the process that we went through was we actually turned the power off to the substation, stripped the board down, replaced the CTs in the back of the cabinet, and then put it all back together again. Now this meant that in turning the power off there was some disruption to customers, and although it did the job, it didn't particularly seem quite a good way of progressing with that. Also, as you can see from the large photograph of the cabinet there, there's a lot of small wiring there. There's a lot of parts there that needed integrating, and this was a first pass that was done for us by GE, which, and again, it looked fairly complicated, and it was fairly complicated for them to build. One of the key issues we had, though, was in terms of turning the power off, and as part of that, we spoke with Ofgem, and they said, we'd like you to do a consultation to say, can you find any better ways of actually doing substation monitoring? Can you find some ways that mean that you don't actually need to interrupt supply? So we put a consultation out, and we came up with a number of solutions, which I'll cover in a moment. About the same time that project started, we did one in Hook Norton in North Oxfordshire. And what that did was develop this. As you can see there, lots and lots of small wiring. We had interface problems there with, in terms of one piece of equipment that was manufactured by one company and a similar piece of equipment manufactured by the same company that wouldn't actually speak to each other. So we had lots of interface issues there with that one. And again, just showing the size of the cabinet there, it's not the kind of thing you would look to put in every substation. We tried using smart meters, and we had a number of issues in terms of those actually working because they weren't particularly fit for purpose, they weren't designed for the purpose. But using large CT clamps, which really we couldn't fit in every single substation. And then finally, really, the biggest project that we've covered now is the LV Sensors Best Buy report, which Roger mentioned earlier. With this one, this came out the back of the consultation. We've been working with NPL to do some laboratory testing, but also some in-field testing as well with both UK Power Networks and ourselves. And a couple of the manufacturers involved in this project are here today. Don Pollock at the back there will recognise the ambient solution at the bottom left-hand corner. And there's a new version of that one out which actually comes in one cabinet rather than in several, which is really good. But also, there were a range of different current transformers that came out of that. And as you can see, there's quite a range of different solutions there. Some of them very flexible and easy to fit in around cables. Some of them, including the one at the bottom left, weren't fit for purpose. We just looked at them and said they weren't particularly safe, although they were accurate. So we've learned quite a lot through this project. And the findings for this one will be coming out later on this year. So where's this left us? This has left us with one of our large tier 2 projects, Falcon, where we've ended up selecting this piece of equipment from GridKey. Very much plug and play, put it on the wall, it turns on, it works, it sends information back. In terms of connecting all the different sensors, very, very easy. Those are the sensors there. We managed to install this one on 5 legs on a substation in about 70 minutes. So some of the ones we did in the LV Sensors trial, it took us 2 hours just to wire them together, let alone actually get the thing commissioned and on the wall. And there's the other thing with this, the form factor is so small we were able to actually fit it on the inside of the cabinet door there. So that's kind of a quick run through our journey we've had as Western Power and what we've learned in terms of substation monitoring. We've seen how it's moved incredibly quickly over the last 2 years. We now know that some of the things we've done in Hook Norton and we did on the LV Sensors project, we wouldn't do that route again. It's just too intensive. So I want to thank you very much for your attention. If you want to find out any more about the projects that we're doing, westernpowerinnovation.co.uk is updated regularly, and if there's any further questions, feel free to email them through.